While sixth-generation fighters from the world's major military powers remain confined to blueprints and conceptual renderings, China's J-36 fighter jet has already conducted successive prototype flight tests. Is this merely a coincidence of technological iteration? Or has China's aviation industry quietly ushered in the next generation of aerial warfare revolution? Recently, a set of images circulating online and a January 30th report by Military Observer magazine have once again drawn global attention to this mysterious fighter. The fourth prototype, suspected to be the J-36, has taken to the skies. Not only does it retain the previous prototype's lack of petal tubes, but it also clearly displays flexible split-type drag rudders and enhanced electro-optical detection equipment in the cheek area for the first time. These details all suggest the project is advancing at an astonishing pace toward finalization and mass production. As a military blogger who has long tracked cutting-edge weaponry developments, I feel compelled to delve into the technical implications and strategic significance behind this advancement for our audience. This is not merely about the future of the Chinese Air Force. It could potentially redefine the global balance of air power. Reviewing the J-36 project's unveiling journey resembles a documentary of technological sprinting. As the world's first sixth-generation fighter powered by 3 engines, the J-36 has progressed rapidly and steadily from conceptualization to frequent prototype iterations. It's important to understand that sixth-generation fighters, as the next-generation air superiority platform succeeding fifth-generation aircraft, typically require extraordinary stealth capabilities, AI-assisted decision-making, collaborative combat capabilities, hypersonic potential, and omnidirectional perception. Developing such fighters demands overcoming multiple technological barriers in materials, propulsion, electronics, and software. Traditional aviation giants like the United States have garnered significant attention with their next-generation air dominance program. Yet no airworthy engineering prototype has been publicly unveiled to date, mostly models or concept drawings. Europe's future combat air system, spearheaded by France, Germany, and Spain, remains in the joint development and negotiation phase. With the prototype's maiden flight anticipated after 2030, Russia's sixth-generation aircraft concepts, such as the PAC-DP or MiG-41, have long been shrouded in secrecy, with only sporadic rumors and no tangible progress. The UK's Tempest sixth-generation concept, while visually striking, remains confined to full-scale models and digital renderings. In contrast, China's J-36 has already conducted flight tests with multiple prototypes, from the third prototype's maiden flight on December 25, 2025, to the fourth prototype's emergence just 1 month later. This rapid iteration pace not only astonishes observers, but also highlights the profound capabilities of China's aviation industry in project management, technology integration, and manufacturing efficiency. Regarding this fourth prototype, subtle exterior modifications indicate the project has entered advanced testing phases. Most notably, the tail features a distinctly segmented, flexible split-fin rudder, a core aerodynamic control innovation tailored for tailless flying wing configurations. As we know, the J-36 employs a stealthy flying wing-like aerodynamic design, eliminating traditional vertical stabilizers to reduce radar cross-section. However, this approach introduced challenges in yaw control. The flexible split rudder functions like an intelligent crack at the tail. By controllably opening and closing, it generates yaw torque while also serving as a decelerator and maneuvering aid. Its flexible material seamlessly integrates with the fuselage, significantly preserving the stealth profile. This design represents a pioneering advancement among global fighter aircraft, likely drawing from accumulated technologies in spacecraft or UAVs. Its implementation indicates that the J-36's aerodynamic layout and structural integrity have been validated through preliminary testing. With its fundamental flight envelope already established, development efforts are now focused on advanced control systems and stealth optimization. Another highlight is the newly added distributed electro-optical aperture system beneath the nose. Comprising multiple sensor nodes embedded within the airframe, it enables 360-degree all-around situational awareness without compromising the stealth profile. This means pilots can see through the cockpit in real time using fused electro-optical data, eliminating reliance on traditional radar scans for early warning of air, ground, and sea threats. This significantly enhances battlefield survivability and the ability to strike first. Additionally, the more distinct appearance of the pylon-mounted electro-optical detection equipment on this prototype likely indicates that the onboard active phased array radar or other RF sensors have entered the installation and testing phase. The aircraft is transitioning from a basic flight platform to the integrated verification of its comprehensive avionics and weapons systems. These technological leaps did not occur by chance. They stem from the accumulated strength built over the past 2 decades in China's aviation industry. From the successful development and deployment of the fifth-generation J-20 fighter to the rapid advancement of the J-35 carrier-based fighter, China's supporting systems, including aviation engine manufacturers, electronics technology, and materials, have formed a virtuous cycle. The J36 triple-engine configuration is speculated to comprise two conventional turbofan engines paired with a variable cycle or combined cycle power unit optimized for hypersonic flight or cruise. This arrangement delivers unprecedented thrust redundancy and mission flexibility, enabling seamless performance across supersonic cruise, extended loitering, and high maneuver dogfighting. The embedded atmospheric data sensor, replacing traditional pitot tubes, was already implemented in later variants of the J-20. By utilizing multiple pressure sensor ports across the airframe to calculate airspeed and angle of attack, it minimizes external components that compromise stealth while enhancing data accuracy and reliability. From an international perspective, the rapid advancement of the J-36 has undoubtedly sent shockwaves through the global defense community. While the U.S. military and think tanks have repeatedly warned about the pace of China's aviation technology progress in recent years, the successive appearances of J-36 prototypes may still have exceeded many expectations. This reflects China's institutional advantage in defense R&D, concentrating resources to tackle major projects, alongside the healthy ecosystem of competition and complementarity among enterprises like Chengdu Aircraft Industry Group and Shenyang Aircraft Corporation. As noted in the original text, SAC's sixth-generation J-50 program is also advancing in parallel, suggesting China may be exploring diverse technical pathways to ultimately develop a sixth-generation aircraft family featuring complementary high, low-end variants or mission-specialized models. In contrast, Western projects often face delays due to budget disputes, policy shifts, and friction in multinational collaborations. China, however, has achieved leapfrog development through stable investment, a vast pool of engineers, and a transition from imitation to independent innovation. For military enthusiasts and observers, the most pressing question may be, when will the J-36 truly enter service? The article notes that the widely circulated 2028 deployment timeline is not entirely unfounded, based on current progress. The fourth prototype has already begun testing sensors and weapon systems, with subsequent key verifications, such as fire control radar, internal weapons bay launches, and electronic warfare equipment, likely to follow soon. Following China's military aircraft development rhythm of producing one generation, prototyping another, and researching the next, the J-36 is expected to achieve initial operational capability around 2030 after small batch trials. By then, it will join the J-20 and J-35 to form the PLA Air Force's 5.5 generation plus 6th generation frontline, fundamentally reshaping the aerial landscape across the Asia-Pacific and globally. Particularly its advantages in stealth, sensor capabilities, and propulsion may challenge existing air defense systems and air combat doctrines, prompting neighboring countries and regions to accelerate investments in countermeasures and thereby trigger a new round of dynamic military balance. From a military blogger's perspective, I must emphasize that while the J-36 progress is encouraging, we must maintain a rational outlook. The maturation of any new fighter requires rigorous testing and iterative development, inevitably encountering technical bottlenecks along the way. However, based on publicly available information, China's sixth-generation fighter program has indeed transitioned from following to leading. This represents not only a technological triumph, but also a testament to the nation's comprehensive strength. In the future, as more test footage and data are disclosed, we will gain a clearer picture of the J-36's full capabilities.